Good afternoon, everybody, and Happy New Year to all of you. This is our lecture number 17 of Python for Machine Learning course. In today's lecture, I will explain about a visualization library named Matplotlib. Data visualization is very important in exploratory data sciences, or in many fields. You should have some mechanism of showing your results to people. So the library that I am going to introduce is named Matplotlib. So 1 second, is the video lagging? I think there is some problem with that, my internet connection. Just hold for a moment. Do you have any issue with the video or audio? Can somebody answer?
Video lag, sir.
Video lag, okay. Is that problem still persists? Say maybe, or
no, sir, it's okay.
No, it's okay, no. Okay. Okay, let me see. Oh, so let us come back to the actual topic. So I think most of the people have joined also. So what we will see today is a visualization library named Matplotlib. So for seeing the power of this visualization library, I will just present some example visualizations that the library provides, so that you will have an idea of what kind of visualization you can do. You just have a look at I will show it from the beginning. Kind of visualizations or plots you can build using Matplotlib. So this is this is from Matplotlib library homepage. This is again another open source Python library. So you can build many kinds of charts or graphs. See the kind of graphs that are shown on this website. So these are all written using programs, so simple programming constructs. So you can, the beauty of this system is that they have provided almost every kind of graphs as examples. Only thing is that you have to adapt that to your data. So for example, if you want to build this kind of a chart for your project or your report, see, you can just go to this chart. So there they have written the code, how this is done. So this looks very simple. Maybe at the end of my today's lecture, you will be able to understand what these things are. So that is how, say, 4 or 5 lines of code will give you this. So there are a lot of examples also. So you can actually get the code. I mean, you can actually incorporate this into your own code very quickly. So so let us go to today's lecture slides. So let me present that. Yeah. Yeah, 1 second. Are you able to see this? No. So Matplotlib package. So my initial portion, I think I already explained. Matplotlib has a lot of capabilities. It is a cross-platform library. It can work on different kinds of displays, whether it is operating systems or different kinds of environments. So it is a widely used thing. So let us start using Matplotlib. So as I told you, Matplotlib is just another library. Just as we use NumPy, we can import that into your program. So if importing Matplotlib into your program is done as this. See here, this is the matplotlib pyplot interface. This is a Python interface to that. So as a Python object, you can import matplotlib into your program. So this is generally we import numpy as np. So this is the one we generally use. Similarly, as a convention, people use this PLT. You can import it as anything, any other valid name, but PLT is the general name that people use. Then now this line is needed only for if you are using Jupyter notebook. So this particular line, matplotlib inline percentage matplotlib inline. This particular line is just for your Jupyter notebook only. If you are writing a real program, you don't need this. So this just says that, say, your output will be, or display will be inside your notebook. Not a notebook like other display cheyana within notebooks display cheyana ennu parayanayitana idu upayogikkune. Then so once you have imported this, so you can use the plot library or plot function to plot 2D data. So let us have a look at a simple example. So for the example scripts, so I have used 2 hypothetical data sets. So these data sets I just wrote yesterday night for the class. So one list is called a temperature. So let us say temperature at Attingal, temperature at our College of Engineering Attingal over a month. The maximum, maybe let us make it as the maximum temperature per month, every month. So assume that every month we are recording temperatures. So these 12 values represent maximum temperatures recorded at our college. So this is just a hypothetical example. And the second data that is again hypothetical is the rainfall in, say, millimeters. Etra millimeter മഴയാണ് ഈ ഞാൻ നമ്മുടെ കോളേജിൽ പെയ്തത് എന്നുള്ള ഒരു മന്ത്ലി ഓരോ മാസം എത്ര മില്ലിമീറ്റർ മഴ പെയ്തു, അല്ലെങ്കിൽ മാക്സിമം ടെമ്പറേച്ചർ എത്രയാണ്, എത്ര മഴ പെയ്തു എന്നുള്ളതിന് സ്റ്റാറ്റിസ്റ്റിക്സ് ആണ്, അല്ലെങ്കിൽ ആ ഡേറ്റ ആണ് ഞാൻ കൊടുത്തിരിക്കുന്നത്. അപ്പൊ ഈ ഡേറ്റ ഞാൻ വെറുതെ ഉണ്ടാക്കിയതാണ്. These are not real data, but you can get real data from your AMD website or meteorological department or some many other websites. They provide the real data, such real data. So our purpose is to explore this particular data. Here, particular data we will explore it. Engane plot it. Engane namakku useful ആയിട്ടുള്ള രീതിയിൽ interpret ചെയ്യാമെന്നാണ് നമ്മൾ ചെയ്യാൻ പോകുന്നത്. അപ്പോൾ maybe in the next couple of classes we will be using these 2 things. So the first thing we do is we will plot the rainfall. Let's see, just see, we defined the data sets here. And this data sets can come from many, say, some file or Python file or Excel file or some other web source, or many sources for data is there. I have already imported matplotlib pyplot as PLT here. So plt.plot rainfall. I'm plotting rainfall. So this is actually the actual plotting command. And this second plt dot show, it is the actual rendering command. It renders on your display. So in the case of Jupyter notebook, this may not be necessary always. This particular statement may not be necessary. But if you are using if you are sending your output to a real display or some TV screen, some other graphical device, definitely you will need it. So make it a practice to that one. You plot it using some plot command, and finally you write a show statement. So these are the 2 things you need to build a basic plot. And among that, even this is not mandatory if you are using your Jupyter. So let us run this particular thing and look at how does this look like. So what happened? I made some mistake here. Where is the mistake? PLT. Oh, I did not import. I did not run this. So I did not import that. Okay, I did not run the first code. Now, secondly, I'm running this. Okay. Now, where is this? Okay. See this. This has come. Okay, let me clear all outputs first. So because I had run the code yesterday night, clear all outputs clear. So let's start from the beginning. So here, let me run this one, and then this one. Okay. So this is the plot. So you have a look at the rainfall. I have plotted rainfall. So it starts with the. So look at the x-axis. Look at the y-axis. 0, 1 up to 10. See, that is not what we need. We need, when you plot a single value, see, x-axis is taken as this list index. This list index aatana x-axis. But this list index 0 മുതൽ 11 വരെ. 0, 1, 2, 3 up to 12, up to 11, including 11. So x-axis is 0 up to 11 വരെ plot ചെയ്തു. അപ്പോൾ x-axis value ആയിട്ട് അതിന് ഇൻഡെക്സ് എടുത്തു. y-axis value ആയിട്ട് ഇവിടെ നമ്മൾ കൊടുത്തിരുന്ന വാല്യൂ. അപ്പോൾ against say 0, it plotted 2. And maybe 0 here. Again, see that curve was plotted. So first thing we need is a proper x-axis. So when you are going to plot a 2D plot, you need two axes. രണ്ട് ആക്സിസിലും കൃത്യമായ കാര്യങ്ങൾ വേണം. അപ്പോൾ y-axis plot ചെയ്യേണ്ട കാര്യം നമ്മുടെ ഡേറ്റയിലുണ്ട്. So what is your x-axis? X-axis should be months. 1 മുതൽ 12 വരെയുള്ള മാസങ്ങളായിരിക്കും നമ്മൾ x-axisലുണ്ട്. So what I did was I just modified one more thing. I defined one more variable, month, with a range command, 1 to 30. So now let me modify it slightly. So I gave two values, an x value and a y value. So x, y. X is first value, month. Y value is rainfall. So let us run it again. So let's show. Now let us see. Yeah, now it's good. See, it is 1 here, 2. Now again there is some small problem. We will solve it now. See, the tick marks here are not proper. So I should ideally show 1, 2, 3 up to 12. So we will come to that. We'll fix that. Otherwise, your plot looks fine. So there is an x-axis value. There is a proper y-axis. So this is how you begin your plotting. So there are only 2 lines. Say this is your plotting command, and this is your show command. plt.plot, month, x-axis, x value, y value. So the plt is the object or plot object you got from pyplot. You are invoking one method of this particular object. Okay. Now let us look at that other one, temperature also. Let us look at the temperature also. So temperature looks like this. See, again this x-axis is not properly shown. It is showing alternate values here. So now let us do one more thing. Let us plot both of them together. Let's see how does it look like. See, I am plotting to a single plot x, the temperature as well as rainfall. Now it looks the other value was plotted with a different color. So now there is one problem, which is temperature, which is your temperature, which is your rainfall. We don't have any clue. Like you plot kanda aalukku manasilavilla. Now we will slowly modify this plot so that we add some title here, some x-axis values here, some y-axis values here, and so on. So let us go ahead. Let's go ahead. So our x-axis, and so what we are going to do is we will rename x-axis. We will add some text here to y-axis to indicate what does it mean. Then maybe we will add a total title to your plot. So this way we will go ahead. So let us slightly modify this. So this is the modification there. So let me look at the rainfall plot. So I'm going to plot, right? See, where is your M? Okay, I think it should be month. I made it again. Month. So that is another mistake that I did. Okay. So let us run this. So this is just a plot. Now let us add, say, labels on for x-axis and y-axis. So what I do is I will add one more command, y label. Y label will add a label to the y-axis, and x label is a label for the x-axis. And I did one more thing. I defined one more variable called ticks. Ticks 1, comma 30. 1, comma 30. Then I put equal to ticks. So let us run this and see. I have made 3 changes, and I'll explain what does it mean. See here. My x label has appeared here as month. You see here what I did? This is my x label. plt.x label. Within brackets, the label to be printed there. Label printed. Similarly, y label, plt.y label comes like this. See, rain fall in centimeters. So this is the y value. Now this plot looks nice. So now I added one more thing. Maybe see, in the previous plot, the tick values or these values shown was 2, 4, 6, etc. This is not what we need. We need for proper interpretation, we need the month properly. 1, 2, 3 കാണണം. അപ്പോൾ അതിനു വേണ്ടിയിട്ട് ഞാൻ അവിടെ ടിക്ക്, ഇതിനെ ടിക്സ് എന്നാ വിളിക്കുക. ഇവിടെ ഗ്രാഫിൽ ടിക്കുകളിൽ എന്തൊക്കെ വരണം എന്നുള്ളതിന് വേണ്ടിയിട്ട് ഞാൻ വേറൊരു വേരിയബിൾ ഉണ്ടാക്കി. You can use the month variable, no issue. But for the clarity, I added one more variable called ticks. So with the range 1 to 30. So it will be 1 to 12 in the real practice. So then to the plot, I added xticks. Xticks എന്ന് പറഞ്ഞൊരു മെത്തേഡിലേക്ക് ഞാൻ ടിക്ക് എടുക്കേണ്ട സ്ഥലം, ടിക്ക് കാണേണ്ട സ്ഥലങ്ങളുടെ ലിസ്റ്റ് അങ്ങ് പാസ് ചെയ്തു. Then you see this displays properly. Now our plot has become a proper plot. 1, 2, 3 up to 12. So this is a month. This is your rainfall in centimeters. Now this our plot looks nice. Now let us plot them together. Let us see. There are 2 values, no? Your temperature and rainfall. I have copied the temperature and rainfall to this cell so that we can easily see that. So ഇത് മുകളിൽ ഡിഫൈൻ ചെയ്തിട്ടുണ്ട്. ഞാൻ താഴെ ഒന്നുകൂടെ കൊണ്ട് കോപ്പി ചെയ്യുന്നുള്ളൂ, നമുക്ക് എളുപ്പത്തിൽ കാണാൻ വേണ്ടിയിട്ട്. Now xticks is here. Now I have that month I have defined again. So let me delete this. So temperature variable ഉണ്ട്, rainfall ഉണ്ട്, month ഉണ്ട്. Month is 1 through 30. So these are the 3 variables. Let me plot both of them together again. See here, month rainfall, temperature, month temperature. Let me plot it. Run this again. Now you see all the same problems are here. Your ticks are not proper. Your x label is not there. Y label is not here. We can add it as usual. But now let us look at the 2 curves. There are 2 curves, one in blue, one in yellow. Now say we will add the title. We will add a title to the. See, I added one more line here called a plot in the title. So temperature and rainfall at Ingle. See, the other things are same. The other code is same. Plot x rainfall, temperature plot. Then at the top I want to print something. So let us run and see what happens. See here. See the plot. ഇതിന്റെ ടോപ്പില് എന്താണ് ഈ പ്ലോട്ട് കൊണ്ട് ഉദ്ദേശിക്കുന്നതിന് ഒരു ടൈറ്റിൽ എഴുതി. Now let us again make it better. പക്ഷേ ഇത് കാണുന്ന ഒരാൾക്ക് ഈ ടൈറ്റിൽ അല്ലെങ്കിൽ ഈ പ്ലോട്ട് കാണുന്ന ഒരാൾക്ക് ഇതിൽ ഏതാ ടെമ്പറേച്ചർ ഏതാ റെയിൻഫോൾ തിരിച്ചറിയണ്ടേ? They may not be knowing that. Somebody who is watching or viewing this plot, they should have an idea about which is your temperature, which is your rainfall. So what we will do is we will add some kind of a legend here. The blue indicates something, yellow indicates something else. So for that, the same code, I haven't changed anything else. Say exactly same here up to this point, everything is same as previous cell. So your defined temperature, rainfall, month, then plotted and added a title. Now, we added two things. We added temperature, two legends. Two legends. And legend adding. One of the legend temperature, രണ്ടാമത്തെ legend. But now, okay, now there may be a problem. Okay, let's see. Now let me run. Let me run this. So this shows the legend as temperature here and rainfall here. So you see, it just got interchanged because this is our rainfall, I think. Now is it? Rainfall starts as this is correct now. Okay, that is correct. Now this order also matters actually. If you change it, this will come the other way around. Suppose this, you can actually try interchanging these two, rainfall and see, and experiment whether there is a it comes in the other way around. You can just try that. Okay. So this is how you build a proper plot. So you will have some data. Then you need, for 2D plot, you need two things: an X value and a Y value. X value as well as Y value. So for the X value, maybe if you don't specify that X value, so I'll explain it again. So for making a 2D plot, you need two sets of data. So one to plot in the x-axis, the other one for y-axis. So you can plot using the plot method of matplotlib pyplot. So if you import that as a plt.plot, say xy will plot it. You can specify multiple values in a single line. Multiple values. So ഇങ്ങനെ പ്ലോട്ട് ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് വേണ്ട ഇതിന്റെ കൂടെ ഒന്ന് എക്സ് ആക്സിസിന്റെ ലേബൽ വേണം. എക്സ് ആക്സിസ് എന്താണെന്ന് കാണിക്കാനായിട്ട് എക്സ് ലേബൽ എന്ന് പറഞ്ഞൊരു കമാൻഡ് ഉപയോഗിക്കാം. വൈ ആക്സിസ് എന്താണെന്ന് കാണിക്കാനായിട്ട് വൈ ലേബൽ എന്ന് പറഞ്ഞ കമാൻഡ് ഉപയോഗിക്കാം. ഇനി ഇൻഡിവിജ്വൽ പ്ലോട്ടുകൾ എന്താണെന്ന് എങ്ങനെയാണ് ഇൻഡിക്കേറ്റ് ചെയ്യുന്നത് കാണിക്കാനായിട്ട് ലെജൻഡുകൾ ഉപയോഗിക്കാം. That is what so what we have seen so far is how to plot a legend, how to plot a title, X label, Y label, and ticks. Ticks are actually the ticks on the x-axis. So I've shown you X ticks. You can have Y ticks also. This is a general scenario of a XY plot. Now let us go ahead and see few more examples. Okay, let's again. It's a tab. Okay, we are here. Let us plot a sinusoid or a sine wave or a cosine wave or some kind of trigonometric functions, or let us plot some kind of polynomials, etc. That is what we generally do. നിങ്ങളുടെ സിഗ്നൽ പ്രോസസ്സിങ്ങോ അല്ലെങ്കിൽ എന്ത് തരം മറ്റേ പ്രോഗ്രാമിംഗ് ചെയ്യേണ്ടതോ അല്ലായിട്ടുള്ള ലാബ് എക്സ്പെരിമെന്റിലൊക്കെ ചെയ്യുമ്പോൾ പ്രോബബ്ലി യു വിൽ ഹാവ് എ പ്ലോട്ട്സ്. അങ്ങനെ പ്ലോട്ടുകൾ മോസ്റ്റ് പ്രോബബ്ലി യു വിൽ ഹാവ് പ്ലോട്ട്സ് ഫ്രം സിനുസോയിഡ്സ്, പോളിനോമിയൽസ് ഓർ സം അതർ ആർബിട്രറി ഫങ്ഷൻസ്. അപ്പോൾ അത് ചെയ്യുന്നത് എങ്ങനെയാണെന്ന് നോക്കുക. സോ the first thing, we will plot a sine wave. We will plot a sine wave from 0 to 6 pi. So I'm going to plot a sine wave from 0 to say 6 pi. So that's, you will see some 6 cycles. 6 cycle ഒരു സൈൻ വേവിന്റെ കാണണമെന്ന് എനിക്കുണ്ടായി. അപ്പോൾ ഞാൻ അതിന് ചെയ്യുക, എനിക്ക് 6 സൈക്കിളിൽ 0 to 6π വരെയാണ് എനിക്ക് പ്ലോട്ട് ചെയ്യേണ്ടത്. സൈൻ വേവിന് പ്ലോട്ട് ചെയ്യേണ്ടത് 6π വരെയാണ്. സോ ദിസ് ഇസ് വാട്ട് ഐ ഹാവ് ഡൺ. സി ലുക്ക് ഹിയർ, I have highlighted here. I am creating the data for x-axis. X-axisന് വേണ്ട ഡേറ്റ ഞാൻ ഉണ്ടാക്കുകയാണ്. അപ്പോൾ ആ ഡേറ്റ 0 മുതൽ 6π വരെയാണ്. That is what I have written here. 0 from 0 to 6π. You create a linear space, linearly spaced data set of with 100 values. Between 0 and 6π, you choose 100 linearly spaced values. So that is what my code here says. So what I will do is I will let me do one thing. Let me show this. How does this look like? And so let me comment this hash. So one more hash will do. So let me comment both. So I am just importing numpy, and I am creating x. So let me print x. So run. So it created an array, equally sized array, up to say 6π. 6π is around 18 point something, up to 6π. So I created values for my x-axis here. Now let us delete this x. Now using this x, so my x is now linearly spaced 0 to 6π. Using this, I am creating y. My y is created sine of x for each value. So see, this is a x is a array, npy array. Npy array edutittu ഞാൻ sin x ലേക്ക് കൊടുക്കും. Now let us print y and see how does it look like. So the sign of each from the values was created. See here. Now we will plot x and y. Now we will plot x as well as y. So here, so let me uncomment this. Now you will get a proper, what happened? Oh yeah, my plot, yeah, intent. Okay, that is something which we forget always. Yeah, so now you see here. See the plotted value here. So it starts from 0, say, then here is 1π, 2π, 3π. So 6 cycles, 3 full cycles of sine wave is shown. So what I did was I created a linearly spaced array between 0 to 6π. I took the values and then I plotted it, simply plotted it. Okay. So you can plot many things. You can plot, say, okay, let us. You can maybe 0 to 10. 0 to 10 you can do. Say maybe we will create something like 10π or some value. This is another example. I am creating a linear space here, x, and this is my y. Y is sine of x. And this is cos of x. So let me, I am adding things like this, x-axis, y-axis line, and a title, legend, etc. So all these things we have seen. So let me run it. Now you look at it, sine and cosine. So I put legend, this is sine, this is cosine, and some value for x-axis, this is some value for y-axis. Maybe, see, now have a look at the code here. X-axis x label, y label. I have put a title. I have put the legends also, so that you can understand or very easily distinguish this. Okay. Now there are other ways of printing legends which I am skipping. I will be posting this to Moodle. You can experiment with some other extra code that I have written there. And now let us look at working with polynomials. That is another thing we will always be using. Import. So here, let me plot x square, x cube. These 3 things I am going to plot. Linear equation, quadratic, and cubic equation. So x, for x I am using lean space or 0 to 2. 0 മുതൽ 2 വരെയാണ് 30 values ആണ് എടുക്കുന്നത്. 0ക്കും 30നും ഇടയിൽ 30 values linearly spaced ആയിട്ട് value എടുത്തു. Maybe you can do log space also, some other methods also are there. Then I am plotting x, y, z. So x, y, z. Okay, let me do that. Run. Okay. Let me do this. So this is your x, y, x square, x cube. So this is how the polynomials grow. You can even add many other things like x raised to 5. How x maybe let us change it. X raised to say 10. How does it grow? So let me run it again. So these two are growing very slowly. X raised to 10 is growing up very quickly. You see. So this way you can visualize things. Now, okay. One thing I missed is here. Wait a second. Yeah. Wait a second. Okay. Yeah, I did not copy something from my original slide. Let me do it in a moment. Wait a second. I'll do it in a moment. Where is this one? Please wait for a moment. Let me take the original slides that I made. I think I forgot to add a couple of lines here. Visualization examples. Yeah, here it is. Okay, copy. Insert. Okay. Here. Insert cell level. Yeah. No, okay. I think I copied that line here. Now I am going to plot something. So I will show what I'm going to plot. So I told you we have x square, x cube. We plotted x square, x cube, etc. Now let us mark it with some colors, some extra markers, etc. Let me run it. So I just wrote a small, I just wrote a little bit of additions to the plot command. Plot, say x square. Let us look at the first thing. Plot x, comma x. So that is the linear growth, linear thing. This linear thing, let us again plot it separately, and then so that you will have an idea. Exact cell below. So paste. Okay, let me look at this line alone. This particular line alone. So x is here. Say we are plotting x comma x. Then here I have added one more argument. One more argument to the plot. That specifies the color. See, that specifies the color and the line style. See, all our earlier plots where the colors were chosen randomly or by some logic by the Jupyter itself or the Python itself, Matplotlib itself had chosen colors for you. Now, here, by specifying a third argument of line style with colors, you can actually build you can actually build better plots. So this is what my first thing does. Let us look at what is this BS. So second line I did was, so let me copy it and paste it here instead of that, so that you will have a comparative idea. So instead of that, so this is actually blue. B is for blue. R, you can have RGB as colors. RGB. There are other colors also. There is a style guide available on Matplotlib website from which you can look up colors. So this will plot. So let us run it. So it plotted in blue with line style as squares. See, you see the small squares here. Small squares. So the first was run with the red and dash as the line style. We were running with the dash as the line style, and now you have as the right as the line style. If you omit that S, you will get a blue line. If you put a red R, if you put an R here, RS here, you will get a red squares. You will get red squares. So it's very easy to do that. So then the next one is YO, yellow, orange. Yellow, O. So this, so let us see how does this look like. If you plot that yellow, copy this. Let me copy this and come down. So here, instead of RS, I will put this yellow YO. Let us run. Yeah. So instead of squares, it is showing small O's or zero circles, small circles, and yellow color. Yellow color. Now then, see, there are other things like a G. This particular cap will be used here. See the third. See the last one we are using as a marker. You are using that caps. So this is how you create plots with the different colors. Your different colors. I think I will post this to Moodle today. There are some exercises for you. So maybe you can look at the help of plot. Plot in the help, you will get more of values to be done. So here are some of the exercises. Maybe some polynomial you have to post, -4 to 4. Maybe you have to define a range with values. Then A value, B value. You can even vary values A, B, C, etc. and plot it. And since there are some more additional line widths you have to use, you can change the line width, you can size, you can. There are many options for PY plot. So some of them you can even set the marker size, colors. See, the options are virtually unlimited. So there are 3-4 exercises I have given. So I will not explain them, but this you should actually run this code. You should run the code and post it back to our Moodle. So this is a broad overview of your Matplotlib. And I will take one more lecture on Matplotlib, in which I will show you some of the advanced features like multiple sub-figures or floating figures, etc., etc. Some maybe if you are having some experience in MATLAB or some other thing, you may find it much more easy. Maybe even without this, you can survive. So let me stop it, the presentation. Now, as I mentioned, Matplotlib is a huge library. There are a lot of options, lot of things you should know, but it is very difficult to remember also. Remember all of these options also. I personally don't remember anything. So if I want to plot, what I do is I will go to the Matplotlib website. I will show you what I do. If I want to plot some kind of good plots, what I do is I will go to the Matplotlib website. So the Matplotlib website gives me load of examples. So let me go to the Matplotlib website. Okay, 1 second. Let me open it up. Yeah, and I will show you how to. If you want to do excellent plots, how to choose them. Okay, no, not this one. Okay, this is another something else I projected. Where is the Matplotlib? Yeah, here. Documentation. Yeah, go to Matplotlib. This is the Matplotlib website. Here, you have load of examples. Say maybe you can go to the examples. Maybe you can go to the examples of this. So there you will see a gallery of things, many different things. So suppose you want to draw this kind of horizontal bar graph. You go to this, click on that. So this is how that looks like. Say that typical horizontal bar graph looks like. Now, if you look carefully here beyond this one, if you click on each of them, it will take you to a site where you have all the code written. Now have a look at the code. Have a look at the code. It is very easily understandable. You can very easily distinguish between. You can very easily distinguish the code. So it is very simple. See, the first line is your import. Second line is another NumPy import. Now I think I have set some random numbers. Now some defaults. Maybe you can look up what does it mean. Then you have your data, Tom, Dick, Harry, and so. So y-axis, y position you have put, and you have plotted it somewhere here. Set title, then the XLab, insert y-axis things. See, these are all simple things you can very easily emulate. You can read up and build your own proper graphs. So it is better not to by heart it. Only thing is that you should know all your plots are here, all your styles are here. Go there, and if you don't understand a piece of code, if you code, then look at it. Say for example, when I take up this one, I don't know, maybe something here, some one line here, subplots or this one. So you can look for this particular thing on Google. You can Google for this in documentation, and that will give you examples of using this particular function. That is how you should choose, or you should learn. Experimentally, you should learn Matplotlib. Okay, I think we will stop this lecture now.